Come on, students. Recall the expression for time period of revolution of a satellite. You recall banking, angle of banking, optimum velocity. Spin has a magnitude of h divided by 2 pi. Temperature of the source is higher temperature, which is taken as T1. Distance traveled in equal intervals of time. Hello students, this is Samson Deepak, Faculty of Physics, Temple of Excellence, Vidhyaashram, Pre-University, Mysuru. Today, I shall be discussing the Karnataka CET 2014. As the realm continues, a very simplified paper. Matpuna Maklaili, Nivo concept na one hantadal tilkondidre 2014 solving is very simple. Fine. The first question. The question reads, a physical quantity Q is found to depend on observables X, Y and Z. Ali upyogisiruvanta pada nodi observables. Obeying the relation Q equals X cube into Y square divided by Z. Concentrate Madi, the percentage error, absolute error Allah, relative error Allah, percentage error in the measurements of X, Y and Z are 1%, 2% and 4% respectively. Error in X is 1%, Y 2%, Z 4%. I have to find the percentage error in the quantity Q. He says a physical quantity Q is measured as X cube Y square divided by Z. Ili X matte Y matte Z na observables ant karitare. What are observables, students? They are nothing but observed values, or precisely saying they are quantities with error. ಯಾವುದೇ ಒಂದು ಕ್ವಾಂಟಿಟಿಯಲ್ಲಿ ಎರರ್ ಇದ್ರೆ, ಅದರ ಮೆಜರ್ಮೆಂಟ್ ಅಲ್ಲಿ ಎರರ್ ಇದ್ರೆ ಅದನ್ನ ಆಬ್ಸರ್ವೇಬಲ್ ಅಥವಾ ಅಬ್ಸರ್ವ್ಡ್ ವ್ಯಾಲ್ಯೂ ಅಂತ ಕರೀತಾರೆ. ಪರ್ಸೆಂಟೇಜ್ ಎರರ್ ಇನ್ ಎಕ್ಸ್, ವೈ, ಝೆಡ್ is given. We have to calculate percentage error in Q. Previous sessions alli helkottidini nanu. How do you calculate percentage error? Yes sir, we have studied. It is relative error into 100%. So percentage error in Q ರಿಲೇಟಿವ್ ಎರರ್ ನ ಯಾವ ರೀತಿ ಬರಿತೀವಿ? ಡೆಲ್ಟಾ ಕ್ಯೂ ಬೈ ಕ್ಯೂ ಇಂಟು 100% ಮಾಡಿದ್ರೆ ದಿಸ್ ಈಸ್ ದ ಪರ್ಸೆಂಟೇಜ್ ಎರರ್ ಇನ್ ಕ್ಯೂ. ದಿಸ್ ಶುಡ್ ಬಿ ಈಕ್ವಲ್ ಟು percentage error in x cube, x to the power 3. So this is 3 into delta x by x into 100. ಇಲ್ಲಿ multiplication ಅಥವಾ division ಇರಬಹುದು. When it comes to error, it is always the sum. Probably the 100th time I am saying error anta bandaga it is always the sum. So this is plus y square. So 2 into delta y by y into 100 divided by z. Division irli, multiplication irli, error is plus z to the power 1. So 1 into delta z by z into 100. So this is 3 into, this gives you, this term gives you the percentage error in x, which is directly 1% given in the problem, plus 2 percentage error in y, plus 1 into percentage error in z, which is 4. So the answer is 3 plus 4 plus 4, 11%. So the percentage error in Q is 11%. Next one. Which of the following quantities is not a vector quantity? ಕೊಟ್ಟಿರೋ 4 ಆಪ್ಷನ್ಗಳಲ್ಲಿ ಯಾವುದೊಂದು ವೆಕ್ಟರ್ ಆಗಿಲ್ಲ. ಕನ್ನಡದಲ್ಲಿ ವಾಹಕ ಅಂತ ಕರಿತೀವಿ. ಫಸ್ಟ್ PUC you study scalars and vectors. In definition, vector though, it should possess magnitude as well as direction, and adolphing my thought, it should also obey a law of vector addition, either triangle law, either parallelogram law, polygonal law. ಓದಿದ್ದೀರಾ? First weight. Is weight a vector? Yes. Weight ಅಂದ್ರೆ ಏನು? Downward force, some type of force. Force ಅಂತ ಬಂದ ತಕ್ಷಣ it is a vector. Nuclear spin. Spin ಆಗೋದು. ಕ್ರಿಕೆಟ್ ನೋಡೋ ಮಕ್ಕಳಿಗೆ ಬಾರಿ ಬೇಗ ಅರ್ಥ ಆಗುತ್ತೆ. ಲೆಗ್ ಸ್ಪಿನ್, ಆಫ್ ಸ್ಪಿನ್, ಡೈರೆಕ್ಷನ್ ಇರುತ್ತೆ. ಅದೇ ರೀತಿ ನ್ಯೂಕ್ಲಿಯರ್ ಸ್ಪಿನ್, ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಏನ್ ನ್ಯೂಕ್ಲಿಯರ್ ಸ್ಪಿನ್ h divided by 2pi. So nuclear spin has a magnitude of h divided by 2pi, also direction, so it is a vector. Momentum, mass into velocity. Velocity ಬಂದ ತಕ್ಷಣ it is a vector. Potential energy. Energy direction ಇದೆಯಾ ಮಕ್ಕಳ? ಇಲ್ಲ. So when energy has no direction, either potential energy or kinetic energy has no direction. So the term which is not a vector is potential energy. Now third one. A car moves from A to B with a speed of 30 kilometer per hour. ಒಂದು ಜಾಗ A ಇಂದ ಇನ್ನೊಂದು ಜಾಗ B ಗೆ at the speed of 30 kilometer per hour. And from B to A with a speed of 20 kilometer per hour. I have been asked to calculate the average speed of the car. ಮಕ್ಕಳ ಇಲ್ಲಿ ನೀವು ಗಮನಿಸಿದ್ರೆ the only hint I have is it is traveling from A to B with a speed of 30 kilometers per hour and B to A with a speed of 20 kilometers per hour. I don't know the distance traveled. I don't know what is the time taken to travel this distance. I have to calculate the average speed. So the formula I use is V average is 2V1 V2 divided by V1 plus V2. Kindly remember this formula when you are calculating average speed in terms of individual speeds. Distance gottilla, time interval gottilla, individual speeds I know. V average is 2V1 V2 divided by V1 plus V2. Now, do I need to convert this to meter per second? Observe, all the four options are in terms of kilometer per hour. So no need of conversion. My task has become easy. So this is equal to 2 into V1 is 30, V2 is 20 divided by 30 plus 20. 30 into 20, 600 into 2, 1200 divided by 50, 24 kilometer per hour is the answer. See, very simple. Idondu simple formula nenpitkondre, yes, getting the answer is very, very easy. Next one. This is an interesting problem now. A body starts from rest. Very clearly the problem says there is a body which is starting from rest. So very clearly the initial velocity of the body is 0 and moves with constant acceleration for t seconds. It is starting from rest. It moves with constant acceleration for t seconds. Now, it travels a distance x1 in first half of the time and x2 in the next half of the time. I have to calculate the relation between x1 and x2. First half of the time interval x1. Next half of the time interval x2. Andre This is the case of distance traveled in equal intervals of time. First half of the time interval, ಎಷ್ಟು distance cover ಆಗ್ತಿದೆ x1. Next half of the time interval, x2. Clearly he says next half of the time, first half of the time. So very clearly, this is the case of distance traveled in equal intervals of time. So we have a relation for acceleration traveled by a body in equal intervals of time. That is, acceleration equals x2 minus x1 by t square. Or manipulating this equation, at square equals x2 minus x1. Ignore, it starts from rest and travels a distance x1. So we have a relation s equals ut plus half at square. Generally, equation of motion, second equation, s equals ut plus half at square. The first distance traveled is x1, starting from rest. So this is 0. So x1 is half at square. Substituting here, at square equals x2 minus x1 is sikkide namige half at square. Bring half at square to the other side. So this is 3 by 2 at square equals x2. Nodili? at square by 2 ಏನಾಯ್ತು? at square is nothing but x2. See, at square by 2 is nothing but x1. Therefore, 3 times x1 is equal to x2. So the correct option is C, where x2 is 3 times x1. Now the problem says, a person is driving a vehicle at a uniform speed of 5 meters per second. He is driving a vehicle at a uniform speed of 5 meters per second on a level curved track of radius 5 meters. The coefficient of static friction between tires and the road is 0.1 mu kottidare. Will the person slip while taking the turn with the same speed? According to which of these options? Allen kelidare, the person will take a turn on the road with the same speed. When he takes the turn, will the vehicle slip? If you recall banking, angle of banking, optimum velocity. So the optimum speed of a vehicle to move without slipping is root mu r g. Recall this expression. A person, a vehicle, ಒಂದು ಟರ್ನಿಂಗ್ ಅಲ್ಲಿ ಸ್ಲಿಪ್ ಆಗಬಾರ್ದು ಅಂದ್ರೆ its optimum speed has to be root mu r g, or this is root 0.1, radius is 5, g is t, or this is root 5, or you can say v square is greater than 5. So the person can slip only if the velocity is exceeding root 5. So a person will slip if v square greater than 5 meter per second. So B is the option. This is with respect to maximum height. We have already done in the previous session. Please do take this as an assignment. The expression will be maximum height is u square sin square theta by 2g. Simple simplification. Every data is direct. B will be the answer. Force is given. Position is given. Torque has to be calculated. We know vector tau is vector r cross vector f, or you can without direction. So with direction I can mention this as vector r cross vector f. So simplify, you arrive at the answer. Now, what is the period of revolution of Earth's satellite? It's a standard question. Time period of revolution of Earth's satellite. Ignore the height. He says, don't consider the height of the satellite above the Earth. Data is given. Acceleration g is 10 meter per second square. Radius of the Earth 6,400 kilometers. Come on, students. Recall the expression for time period of revolution of a satellite. We write T is 2 pi root of r by g. So please to understand, again a standard expression. This is giving me time period of revolution of a satellite around the Earth. R is the radius of the Earth. G, acceleration due to gravity, or T equals 2 into pi is 3.14 root 6,400 kilometers ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. So into 10 power 3. When you simplify, C is the standard answer. This is a knowledge-based question. You should know with this standard data, time period of oscillation of a satellite around the Earth is nearly 84 minutes. It is a standard knowledge-based question. The ninth one, very simple. Period of geostationary satellite. Geostationary satellite revolving around the Earth with the same period of revolution, which is, yes, 24 hours. What is the source temperature of Carnot's engine? Source temperature ಕೇಳಿದ್ದಾರೆ. Required to get 70% efficiency. Eta efficiency is 70%. Given sink temperature is 27 degrees Celsius. Note friends, source temperature, temperature of the source is higher temperature, which is taken as T1. Temperature of the sink is the lower temperature, which is taken as T2. Temperature of the source, higher temperature, T1. Temperature of the sink, T2. Efficiency is given. So all of us know efficiency is 1 minus, yes, come on. Efficiency is 1 minus T2 by T1. Now, so efficiency is 70%, which is 0.7, which is 1 minus. T2 is given to be 27 degrees Celsius. Kelvin convert ಮಾಡ್ಕೊಳ್ಳೋಣ. 300 Kelvin by T1, or 0.3 is 300 by T1. I'm taking 1 towards the other side. 0.3, 1 minus 0.7, 0.3 equals 300 by T1, or when you simplify, T1 is 1000 Kelvin. But you see, all the answers are in Celsius. So this is 1000 minus 273. So the answer is 727 degrees Celsius. Next one, very important. A nice question. A 10 kg metal block, mass kotputru. There is a 10 kg metal block attached to a spring, whose spring constant is 1000 Newton per meter. Andre ಒಂದು vertical support ಇರುತ್ತೆ, to which a spring is attached, and to this spring I have suspended a metal block of mass 10 kg. The spring constant of the spring is 1000 Newton per meter. The block is displaced from its equilibrium position by 10 centimeter and released. Andre, from its equilibrium position, it moves by a distance of 10 centimeter and released. Maximum acceleration of the block. Andre, when the spring is released, as the problem says, it is released. When the block is released, the spring executes simple harmonic motion. And you know, maximum acceleration during simple harmonic motion is minus omega square A. You have to know this. Maximum acceleration, that is what is asked. ಏನ್ ಕೇಳಿದ್ದಾರೆ? ಆ ಒಂದು ಬ್ಲಾಕ್ ನ ರಿಲೀಸ್ ಆದಾಗ ಸ್ಪ್ರಿಂಗ್ ಸಿಂಪಲ್ ಹಾರ್ಮೋನಿಕ್ ಮೋಷನ್ ನ ಎಕ್ಸಿಕ್ಯೂಟ್ ಮಾಡುತ್ತೆ. What is the maximum acceleration in that case? Maximum acceleration during simple harmonic motion is minus omega square A, where omega angular frequency ಅಂತ ಕರಿತೀವಿ, A amplitude ಅಂತ ಕರಿತೀವಿ. Omega is not known, but I know omega is root k by m. ಈ ಎಲ್ಲ ಎಕ್ಸ್ಪ್ರೆಷನ್ಸ್ ನೀವು ತಿಳ್ಕೊಂಡಿರ್ಬೇಕು. ಇನ್ ಟರ್ಮ್ಸ್ ಆಫ್ ಸ್ಪ್ರಿಂಗ್ ಕಾನ್ಸ್ಟೆಂಟ್, root k divided by m, or this is root k, spring constant is 1000, mass is 100, root 100, 10. I've got the value of omega. So substitute here A max minus omega is to 10 square. So 100 into amplitude is 10 centimeter, 0.1. So the answer should be 10 meter per second square, because this is 100 into 1 into 10 power minus 1 square into, so 10 to the power 1. So the answer is 10 meter per second square. What is the significance of this negative sign? Yes, it shows restoring force acts opposite to the applied force. Very good. Now, a metallic wire of 1 meter length has a mass 10 into 10 power minus 3 kgs. ಒಂದು ಮೆಟಾಲಿಕ್ ವೈರ್ ಇದೆ, whose length is 1 meter, has a mass 10 into 10 power minus 3 kg. A tension of 100 Newton is applied to that wire. Then what is the speed of the transverse wave? If you remember again, velocity of the transverse wave is root t divided by m. ಇದನ್ನೆಲ್ಲ ನೀವು ನೆನ್ಪಿಟ್ಕೋಬೇಕು, ಈ ಕಾನ್ಸೆಪ್ಟ್ಗಳಷ್ಟೇ. If the concept is drilled thoroughly, then you can see what mathematical simplifications I need. But if I don't know the concept itself, andre, I will never judge a fish wrongly because it cannot climb a tree. But if the fish cannot swim in water, then it's a question mark. Your aptitude to solve physics depends on how good you know the concepts. So the speed of the transverse wave, V equals root of t divided by m, where t is the tension applied and m is mass per unit length, capital M by L. Mass per unit length ant karitivi. So capital M by L, which is 10 into 10 power minus 3 divided by L is 1. So substituting here, so this becomes root t is 100 divided by 10 power minus 3. So simplify this, a very simple answer. So this is root, so this simplifies 10 into 10 power minus 3 goes to the numerator, or root 10 to the power 4. This is 10 to the power 2. So the answer is 100 meter per second. Nodi? Simplifications. That's oral simplifications. You don't need a calculator to do this. Good. This is already done. Question on Doppler effect. Please refer back to the previous session. 350 hertz. The same problem is the answer. Now, a rotating wheel, rotation, rotational body dynamics banto, rotations, changes the angular speed from 1800 rotations per minute to 3000 rotations per minute in 20 seconds. What is the angular acceleration assuming to be uniform? Initial angular velocity, final angular velocity. So angular velocity na yav reeti donate martivi? Omega. So here omega 1 is 2 pi f1. Omega is always 2 pi f. Time periodally 2 pi divided by t. Since per minute kottidare frequency 2 pi f1, or this is 2 pi f1 is 1800 per minute allide. So seconds convert ಮಾಡಬೇಕು. So this is 60 pi radian per second. Similarly, final angular velocity 2 pi f2. This is 2 pi f2 is 3000 divided by 60. Again this goes 50 times. So this is 100 pi. When you know initial velocity and final velocity, how do you calculate acceleration? Similarly here, angular acceleration alpha is omega 2 minus omega 1 by t, which is 100 pi minus 60 pi, t is 20. So 40 pi by 20. So the answer is 2 pi radian per second. Nodi, ಎಷ್ಟು simple ಇದೆ. A flow of liquid is streamlined if the Reynolds number, streamline flow, critical flow, turbulent flow. So it is streamlined if the Reynolds number is less than 1000. So what is Reynolds number giving me? The nature of flow of a liquid. If the Reynolds number is less than 1000, then what is the nature of flow? It has to be streamlined. A pipe 30 centimeter long. There is a pipe 30 centimeter long, which is open at both the ends. Andre, it is an open pipe. Very clearly, the pipe is opened at both the ends. Open pipe produces harmonics, integral multiples of the fundamental frequency, resonance, harmonics ಅಂತ ಓದಿರ್ತೀರಾ. Which harmonic mode of the pipe resonates at 1.1 kilohertz source given speed of sound in air is 330 meter per second? Which harmonic mode resonates a 1.1 kilohertz source? ಏನಿದ್ರ ಅರ್ಥ? ರೆಸೊನೇಟ್ ಆಗೋದಂದ್ರೆ ಏನು? ಫ್ರೀಕ್ವೆನ್ಸಿ ಮ್ಯಾಚಿಂಗ್ ಅಂತ ಅರ್ಥ. ದ ಕ್ವೆಶ್ಚನ್ ಈಸ್ ವಿಚ್ ಹಾರ್ಮೋನಿಕ್, ಫಸ್ಟ್ ಹಾರ್ಮೋನಿಕಾ, ಸೆಕೆಂಡ್ ಹಾರ್ಮೋನಿಕಾ, ಥರ್ಡ್ ಹಾರ್ಮೋನಿಕಾ, which integral frequency will match this 1.1 kilohertz frequency? The source has a frequency of 1.1 kilohertz. So you have to calculate which harmonic is resonating that frequency, which harmonic is matching that frequency, for which I use the relation Fn is n into F1. This is the harmonic mode and this is the fundamental frequency. Now the frequency of the source is 1.1 kilohertz. This is the frequency of the source. I have to calculate what is n, which harmonic is resonating, into fundamental frequency of open pipe. Very good, students. V by 2L, which is the fundamental frequency of the open pipe, or this is 1100 equals n into V ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರೆ? velocity of sound 330, length is 30 centimeter, which is 0.3. On simplification here, n turns out to be 2. So the answer is second harmonic. You can just do this multiplication. So n turns out to be 2. Next one. In anemometer expansion of water, at what temperature density of water is maximum? It is at 4 degrees Celsius. 0 to 4 degrees Celsius, water contracts. Only after 4 degrees Celsius, there is expansion. So at 4 degrees Celsius, density of water is maximum. An aeroplane executes a horizontal loop at a speed of 20 kilometers per hour. So this 20 kilometers per hour is 200 meters per second. With its wings banked at 45 degrees. Angle of banking ಕೊಟ್ಟಿದ್ದಾರೆ 45 degrees. What is the radius of the loop? Now when it comes to angle of banking, we know tan theta equals V square divided by RG. So tan theta equals V square divided by RG. I want radius. So R is V square tan theta into G. So what is the velocity? 200 into 200. Tan theta, tan 45 is 1. G is 10. So the answer is 4,000 meter or it is 4 kilometer. So the answer is 4 kilometer. Now, next one. A body having moment of inertia. Moment of inertia मेल प्रश्न है. The body has moment of inertia which is equal to 3 kg meter square. So how much is the moment of inertia of the body? 3 kg meter square is rotating with an angular velocity of 3 radian per second. 3 kg meter square moment of inertia ಒಂದು body rotate ಆಗ್ತಿದೆ. What is the angular velocity of rotation? 3 radian per second. Kinetic energy, ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ. Please do understand this, highlight on this. Kinetic energy of this rotating body is the same as that of a body of mass 27 kg moving with the velocity v. The value of v has to be calculated. He says kinetic energy expression ಏನು? half mv square is equal to kinetic energy of a rotating body half I omega square. ಇದು ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ ನೀವು. This is the expression for kinetic energy of a rotating body. I current alla, moment of inertia. So half into mass is given 27. We calculate ಮಾಡಬೇಕು into moment of inertia is 3. Omega is 3. Omega square. So 27 and 27. So V is 1 meter per second. See, very simple. So the velocity is 1 meter per second. A tire bursts suddenly. What type of process? Heat neither comes into the system. Heat is not going out of the system. There is a sudden burst. Temperature changes. Yes, it is an adiabatic process.